OK, before we leave web altogether, one thing we can do is try and compare and contrast some of the attacks we've seen so far. So in particular, I think that XSS and SQL injection have pretty similar characters. In both cases, the server is coming up with some HTML website or some SQL query, and they're leaving a blank for the user to fill in. And if the user fills in the blank with some code, then the server accidentally treats the user input as code. So in both cases, we have some template. There's a blank in the template with untrusted data. And if the user inputs something malicious into that blank gets treated as code, like JavaScript, or a command, like in SQL. And so if we generalize this idea, turns out this is something that happens all over the place, and it's sometimes called command injection. And XSS and SQL injection are just two specific types of command injection that work on JavaScript and SQL in particular. But this could happen in any language you could think of. You could write a Python program where there's a blank that the user has to fill in. And if you're not careful, maybe the user's blank gets treated like Python code. That could also be a command injection, where you're trying to concatenate strings and then evaluate it. Maybe you accidentally evaluate the user's input as code. Another example might be in the terminal. So if you remember, in C, there is a function called system. And what system does is it takes the user's string input, the one argument that you pass into system, it opens a terminal, like a shell, and then it runs that command in the shell. So if you call system on a user-controlled input, then whatever the user inputs, it gets executed in the terminal. So it's yet another case where untrusted data is run as a terminal command in this case. So there's lots of different examples of this in different languages. XSS, SQL injection, and the system function are just 3 of them. So here's an example of the system command in action. Once again, the system command takes in one argument. It opens a shell, and it runs that argument as a command in the shell. So if the attacker inputs some non-malicious string, then what we would do is we would take their non-malicious string, we would substitute it into some pre-formulated template, and then we would call system on the resulting string. So what you're supposed to do is you're supposed to have a template. You fill in the user's requested name in this case, and then you call system with this overall command. And then that opens a shell and runs this command, which searches phone book for this particular name. But just like all the other examples, if you instead input something malicious with all of these terminal commands, like the semicolon and the mail command and some reference to the passwords file, if we plug this into the command again and we try to run system on this string, we'll open a terminal, we'll search for nothing, and then semicolon says we're done with that command. We'll start a new command that says, please email to Mallory the passwords file. So now we've emailed the passwords file to Mallory. That's bad. And then at the end, because we want to match up this quote, we write some dummy command that has a quote to match up this quote. This way, the syntax all works out. So this is another example of command injection, but instead of in SQL or JavaScript, it's now in the terminal, in Bash. So the defenses against command injection in general are pretty similar to the ones we've seen for XSS and SQL injection. One thing you should do is sanitize your inputs. But once again, getting sanitization exactly correct can be difficult. If you forget to sanitize a specific character, maybe attackers can use that character against you. So using well-vetted libraries is important. You can also use safe APIs. So nowadays, a lot of languages do something similar, like prepared statements, where instead of directly substituting in a user string and then executing the user string as potentially code or a command, there are safe APIs that let you define a template and then substitute data into the template separately. So in other words, you have separated out the commands and the data that the user has provided. So one example in C would be to use execv instead of system. So if you use something like execv, it would allow you to define this template and then substitute in the string without the string being interpreted as bash code. So that's something you could do. Or in Python, instead of using system, which is unsafe, there's a safer alternative called subprocess.run. And once again, you have to look these things up in a library to know which one is correct. And one example of modern programming designers trying to help you defend against this and thinking about human factors, Go is a relatively new language, I think. And what they did is actually just give you one command, namely the safe one. So they don't even have an unsafe alternative. They got rid of it, so you're not allowed to use it. And this forces everyone to go through the safe one. So that's an example of considering human factors. And something like C has both the unsafe and the safe one, probably because of legacy reasons, so it's a little bit more dangerous.